So let's start with the term, it's an arithmetic sequence. So there's two different ways to pronounce that word. Arithmetic is probably the pronunciation you've used before. That just means adding, subtracting, multiplying, and dividing. In my experience, arithmetic, like that pronunciation, is a noun, and arithmetic in this case is an adjective. So we are talking about arithmetic sequences. So we're going to say it as arithmetic and not arithmetic. But, whatever. Anyway, so here's the important stuff. An arithmetic sequence is a pattern, and it's a pattern that involves either addition or subtraction. So this can be as simple as, something like 2, 4, 6, 8. That's a pattern that's adding by 2. And so we would call that arithmetic. Could also be a subtraction pattern, 100, 90, 80, and so forth. That's also an arithmetic sequence. In this slide, you're going to see a couple different variables. So the first one I want to point out to you is variable D, and D is going to represent the common difference between terms. So like in this first pattern, 2, 4, 6, 8, your pattern is to add 2 each time. And since it is consistently adding 2, then it qualifies as an arithmetic sequence. And we would say that D is equal to 2, meaning the common difference is to add 2 each time. In the second example, the pattern is taking away 10 each time. And so we would say that the D value, the common difference, would be equal to negative 10, just to say take away and not add. Make sense? The other thing you're going to see in this slide is this second variable called C. And so C is basically going to tell you kind of like a y-intercept value for a sequence. Let me try to make a graph. I'm using my airliner right now, and it's not like the most user-friendly item, but I'll do my best. So I'm going to make just a quick graph, and I'm going to just plot, oh boy. I'm going to say like 1, 2, 3, 4. Those will be what are called n values, and those represent like first term, second term, third term, fourth term in my sequence. And then I'm just going to count by ones over here. And what I'm going to do, I made this a little too tall. What I'm going to do is plot that first sequence, that first arithmetic sequence that I posted or wrote at the top. And so I'm going to write for the first term, it was 2. The second term was 4. The third term was 6, right about there. And the fourth term was 8, okay? I'm actually not going to draw a line because sequences only have specific values that they exist within. It's not anything in between. So this would be what a graph of a sequence looks like, just dots. So that C value said A1 minus D. And so A1 is a notation for sequences that means the first term value. So these would be over here called A sub n values. And so your first term value in this sequence is 2. And then D is your common difference. So that's going to tell you like what the pattern was. And the pattern was to add 2, but we're going to subtract that value. So we're going to subtract 2. And so we would get C is equal to 0. And so what C really means, here's the algebraic representation of finding C, but graphically what C means is it means like your y-intercept. So if you were to continue your pattern backwards a step, where would it cross the y-axis? Well, this one goes 2, 4, 6, 8. So if I were to go back a step, I would have started on the y-axis at 0. And so C value is kind of like your y-intercept. Okay, I think it's helpful to think of it that way. The C value is really important when we're writing equations to represent our sequences, which we're going to do here shortly. So keep that in mind. Okay. There's two different ways to write equations to represent a sequence. There's what's called a general form and a recursion formula. So general form on your definition slide will actually be called explicit form. Yikes, my handwriting is terrible. It's called explicit form. And so explicit form is basically a rule that will allow you to plug in any term, and it will give you, or sorry, any term value that you're looking for, and it will give you that corresponding term. So for example, if I had an equation here that represented some sequence and I wanted to know the 500th term in the sequence, I could just plug 500 in for n and then do the computation. It would tell me what the 500th term is. So explicit formulas are super, super useful for sequences. We will be using them a lot. But sometimes what we also do is we do something called a recursion formula. In your definition slide, it is called a recursive formula, not recursion. That's like the plural word for recursive. Anyway, there's three different equations written here. Most of the time, what you're going to see for a recursion formula is you're going to see it written like this second one. And so recursion formula, the way it works is it's like a term by term formula. So I would basically be telling someone like, hey, to find this sequence, you start with this term value. So I'm telling everyone the first number, and you add 6 every time. So recursive formulas are more of like directions for how to continue the pattern, but not as quick as an explicit formula. In that in a recursive formula, it doesn't tell you how to get from step 1 to step 500. You have to do step 1 to get to step 2, and step 2 to get to step 3, and so forth. So it's basically defining everything by the previous term. So we'll work on the notation stuff for that here shortly. Okay, so let's look at an example. It says, find the first 6 terms and the 100th term for the sequence defined by the conditions. And so these conditions in this example are exactly what a recursive formula is going to look like. And so in a recursive formula, 2 things. You have to be given the first term so that you know where to start. And then you have to be told in a second line what to do with that first term. Okay? And so let me break down the notation for you. B sub n would be like your current value, your current term. In this case, my current term, the only one I know, is the first term. And then B sub n plus 1 is going to give you the next term. So then what we're going to do with this is we're going to say, okay, B1 is -3. That means that's my first term. In order to find B2, I'm going to take the current term that I know, well, that's -3, and the formula says to add 10, which means that my second term would be equal to 7. To find my next term, the third one, I would take the current term that I know, which is now 7, and I would add 10, which gives me 17. One more time. So to find the fourth term, I would take the current term that I know, so 17, and I would add 10, and that would give me 27. And so we would just continue this pattern a few times, and then obviously you're going to pick up pretty quickly that really this pattern, if you look at the answers, this is really just adding 10 each time, right? So I can make my list of the first 6 terms really without having to go through the formality again. I can just say I'm adding 10 each time. So the fifth term has to be 37, and the sixth term would have to be 47. Okay. I also have to find the 100th term. I don't know about you, but I would rather not keep adding 10 100 times. That's just going to take forever. So what we can do instead is we can write an explicit formula to represent the sequence and then use it to find the 100th term. So in your explicit formula, what you need, and you can go back to the last slide if you would like, but for an explicit formula, you are going to want to follow the following. This is the formula for like how to set up an explicit equation. So essentially what we're going to be doing is plugging in two things. This is your common difference value that we discussed in the beginning. And then C is like that y-intercept value that we also discussed. So I'm going to do the C value first and just remind you of how that works. So to find the C value, basically think backwards a step in your pattern. So my pattern goes -3, 7, 17, etc. If I were to go backwards a step, what would the y-intercept value be? So take the first term that you know and do the opposite of what your pattern says to do. So our pattern says add 10, so we're going to subtract 10. And that tells me that if I were to go back one step, I would be at -13. So that's my common difference, or my C value. My common difference is just what is the pattern. And in this case, the pattern is to add 10, so the common difference value would be 10. So we're just going to take this stuff and we're going to put it all together and plug in the 10 in place of D and -13 in place of C. And that's going to give us an explicit formula. So I'm going to write that down. Okay, once you have your explicit formula, the cool thing is you're allowed to then plug in literally any value that you want. In this case, we want to know the 100th term, which means that n is going to be 100. So I'm going to plug in 100, and I'm going to do the math. 10 times 100 is 1,000, minus 13 gives me 987. So my 100th term is at 987.